So the problem with most Rust Hello World tutorials is we never actually explain how Hello World works. We always skip on to the next language feature. So things like how the println macro works, how the main function works, how the build and linking works, that all gets glossed over because you're very quickly adding numbers together. And I'm including myself, I've done the exact same thing. So in this video, we're going to strip it back and I'm going to show you actually how Hello World works. But with a twist. We're not going to use the main function. We're not going to use the println macro. We're not even going to use cargo run. We're going to manually build and link it ourselves. And we're even going to understand how the system calls underneath the hood work. And we'll do a little bit of inline assembly so that you know when you look at those 3 lines of code in Hello World in Rust, which is a beautiful thing, you will truly understand what it's doing. So the first thing to understand about any executable is it must have a global entry function, i.e. there must be a starting point. There must be a function that you're going to start and execute within. And in Rust, that is our main function, right? So fn main, and then you call this println hello world. So that is our global entry function. Now, underneath the hood, there's a lot of magic, and I'm going to show you that magic in a second. But by convention in Rust, it must be called main. So if I change that to mainy, or if I change that to something like start, and then I do save, and then if I do try and do a cargo build here, I'm going to get an error. And you can see here, main function not found in Rust Hello Advanced. Consider adding a main function to main.rs. So it's got a convention here, right? So in Rustland, it's basically saying fn main is going to mean my global entry function here. So what we're going to do now is we're actually going to force the situation, and we're going to make start a global entry function. Now, you should never ever do this in your own code, but really this is just for you to understand how much goodness that Rust is giving you and really what's happening underneath the hood in a Hello World program. So if I want to get rid of the convention of having main as my main function, what I can do is I can instruct Rust's compiler to not have a main function. And how I would do that is at the top of my program, I would type hash, exclamation point, square brackets, no underscore main, and then close off my square brackets. And as soon as I do that, what that is going to say is when you are compiling my program, don't go looking for the main function, right? Because there isn't going to be one. So that's kind of useful for maybe if you're building a library or whatever. Or in our case, if we're going to manually build and link the program ourselves, then we're really instructing it that I'm going to take care of this, don't do it. So if I now go back to my terminal, I'll just clear this and we do a cargo build. You can see a whole load of things going on here. So the first thing I want you to see is I'm going to get a warning, obviously, and saying function start is never used. Now that's obvious, right? The key thing is I'm no longer getting this error about, can't find the main function. So we're in a good space. Now, what actually happens is when you start to get these errors, then you start to understand what's happening underneath the hood. So the first thing that's happening here is you can see it's doing a CC archarm64. So what that's actually happening here is it's actually doing the compilation. So underneath the hood here, CC is actually your system C compiler. So there's some compilation going on here. And then it's basically creating a whole bunch of object files. And we'll talk about what that's in a second, because actually, as part of the compilation process, there's essentially 2 stages. You've got your source code, which is your, in our case, is our main.rs, and then that needs to be compiled. So you can see the compilation is going on. In order to get to the compilation, there's a whole bunch of stuff that needs to happen, like parse and lexing, etc. Create an abstract syntax tease, etc. But eventually, as part of the compilation process, what you're going to do is create a bunch of object files. And the object files are really unlinked executables. And then as part of that process, we're going to take all of these object files of our libraries, and then they're going to get linked together. And that's really important for the system libraries. So things like actually doing a print out to a screen is actually an underlying system call, as we're going to see a little bit later. Terminating my terminal, that's a system call as well. So when you're building your application, then underneath the hood, there's going to be these system calls that are happening. and the compiler doesn't know anything about it. So you need the second stage, which is the linker, which is then going to link up any libraries that are external to your source code, which will then allow your code to come together and create an executable. So if we look at the bottom here, you can see there's another error going on here, ld entry point underscore main undefined for architecture ARM64. So a couple of things to understand here is LD is that linker that I explained a second about, and therefore by default, so LD looks for underscore main as its underlying entry point. If I just come back to this diagram there, that LD is that linker. So if we look at this diagram here, what I've got is my main.rs, I've got my compilation to these .o files, and then all of those .o files that are created get linked with that linker. So that LD error that we saw again, that is the linker, and then that creates that executable. And actually, if I just make this code work again for a second, so if I turn that back to a main and get rid of the no main error, and I do my cargo run again, and then it's all working. If I come back into Visual Studio Code and I bring up the target files, let's have a look under here. What I want you to see there is you've got a whole load of these .o files, right? That's those object files. So that, remember that CC that I was showing you with the system compiler, which is Clang in this case? It's actually going to create all of those object files there. That's actually what's happening underneath the hood there. It's building all those sort of dependencies there. We've got a whole bunch, Rust compilers creating a whole bunch of object files there. So we're all in a good space, and then they get linked together to form this executable, which is our Rust Hello advanced executable that we've just created. And actually, if I want to, I could go .target debug and call Rust Hello Advanced, and that's our executable. So if we bring that back to the start function and we get the error that we had before with cargo build, basically what it's saying there, if you look at this entry point underscore main, essentially, remember in the old code it was fn main. Now you can see there's a little bit of convention going on here. So the Rust compiler underneath the hood is essentially taking main and turning that into the label underscore main underneath the hood there, right? So, and now that doesn't exist. The linker is expecting something called underscore main. It's not there, so it can't do the build. Now, if I want to, and this is what we're going to do right now, I could actually manually compile and manually link. So what I'm going to do now is, rather than compiling and linking an executable, I'm going to take that first stage of the diagram and I'm going to use my Rust compiler just to create the .o files, the object files, and then I'm going to manually link using the linker itself. So to do that with Rust, all I need to do is type in rustc -- emit, and I'm going to say I want you to emit an object. So it's -- emit equals obj. And then what I need to do is pass in the name of our Rust file, which in our case is going to be main.rs. So I do the compilation. Again, I'm going to get a function. It says function start is never used. That's fine, blah, blah, blah. And then I get a warning. Okay, but if I look at this, I can now see in my folder there, I can see I've got a main.o. So I've created that object file. So if I wanted to get a different name, what I could do is specify the name of the object file that I want. So let me get rid of main.o for a second. And what we're going to do is we will rerun that command, but this time I'm going to put -o and I'm going to call it hello.o. So now if I do an ls, you can see I've got my object file, which is hello.o. And that's really when you do a cargo build or a cargo run, that's what's happening underneath the hood. Now, there's lots of other things that it needs to do, things to compile for your dependencies, etc. But essentially, it's doing this. So now that I've manually created my object file, if I wanted to, I could actually do the linking myself manually. Yeah, and this is the same process that works for other languages, whether it's like C or C++. Linking is using the exact same linking tool, and the linking tool in this case is LD. So what we're going to do is use the linker to essentially link the compiled object file that we have to the system libraries so that we can create our executable. And remember, the system libraries has got all of the write to screen stuff, it's got all of the termination, etc. So in order to have a working executable, we need to take our source code plus the system libraries, which is your std libraries, etc., to create that. Now, if we look at the call here, you can see LD, which stands for the linker, -o. So what we're saying here is I'm going to output a file called hello. So that's going to be the name of my executable. And then I'm going to pass in as my input hello.o. So that is the source file that I just compiled a second ago with the Rust compiler. And then the -l system blah, blah, blah is essentially saying this is the location all of the system libraries, which have all of those system calls to things like, write to screen, etc. Okay. So, and then finally, what I'm saying here is remember what I said about entry points. So -e underscore main. So in that case, I'm saying go find me the main function. Now, if I took that away for a second and just run that, you can see it's going to say undefined symbols for architecture ARM64 underscore main. So actually by default, the linker is looking for underscore main, but I can use the -e function to say, go use something else. So in this case, I have created a new entry point, which was start, function start. And by convention, what should happen with the compilers is it should take the name, so underscore main, whatever, main, and take it to underscore main, or start and compile it to underscore start. So if we just run that for a second, it's saying it's now looking for start, but I'm still getting an error. And the reason is because the Rust compiler underneath the hood is going to do a whole bunch of mangling of names. So there's a lot of magic going on underneath the hood because the Rust compiler is doing the compiling and the linking. So what it does is it gives it a sort of mangled up name and then does the link. So the good news is we can actually unmangle that. So if I come back to my start function and now I can instruct the compiler via an attribute not to mangle up and generate its own name and actually to follow the standard convention that everybody else does. So to do that, I just put hash and then I put square bracket and then I say no underscore mangle. Yeah. And if I save that and then come back to my terminal and then do my Rust compile again, and now I've got a new hello.o, and now if I do the linking, it should be able to find the start, which it does. And you can see there undefined symbols for architecture ARM64 here. But the good news is I'm not getting any issues with the underscore start because you can see it's actually calling it as reference from underscore start. So it knows what to do with that now, but I'm getting some other errors. And basically there's two things going on. Is that the Rust compiler underneath the hood has got some linking for all the panicking stuff. So that's actually a macro that happens underneath the hood. But then there's also this print macro as well. So as part of the linking process, what actually happens is the print macro the Rust compiler deals with. But because I'm manually compiling this, I haven't dealt with that, so it doesn't know what to do with it. So if I want to get this working quickly, and I'm going to show you how we're going to deal with the print macro in a second, if I want to at least get this compiling and linked, what I can do is let's just get rid of the println macro for a second, and then we're just going to put something simple in here. So we'll say let equals 0. So nothing too exciting. And now we'll just clear this. We're gonna do a compilation again. So we've now got our hello.o object. I'm gonna do the linking one more time, and then you see it works. So there's no errors because there's nothing underneath the hood that it needs to link. But now if I run hello, it works. Now, I'm not outputting anything at this point, but it's actually working. So I've got an executable. I've manually done the compilation with the Rust compiler, and then I've done the linking myself. Now, if I do want to get the linker picking up the right thing here with the println, what I could do is just get rid of the comment there. And then this time, rather than using the Rust compiler directly, I could do a cargo rust c minus big C, and I can put in some link args, and I could say equals, let's say -e, and then we could say start. So I'm basically saying, for cargo here, when you do your build, now use rather than main, use the underscore start. So if we run that, you can see it's done the build there. Go to target, debug, and it's Rust C hello advanced. You can see it's now coming back with hello world. And just to prove that that's all working, I could just turn that into hello. We could do the build again, and then we can run the executable, and you see it does hello. So now, just from using that cargo Rust C and then changing the link args, I can now build my application and not use the main function, and I still have access to the println macro, and it's done all the linking for me, right? I've not had to manually do the linking. But of course, if I want to manually do the linking here, we can do that, and then I can run my linker, and then I'm going to get back to these errors. Now, if I wanted to, I could actually do the same process with C. So if I were just to come out of here and create a new file, which was hello CASM, and go into hello CASM, what I could do is go through the same process with C. So let's do that for a second. We will just create a file called hello C. Let's open that up in Visual Studio Code for a second. And then what I'm going to do here is I am going to include my standard IO libraries. So we'll just put that in there for a second, and then we'll accept that. We'll do an int main there. And you can see there, this is the equivalent C function to my Rust function. There's a couple of things going on underneath the hood there that Rust is taking care of us that we don't really need to take care of. So the first thing is Rust is actually dealing with all the standard I/O, so all the kind of log into screen stuff, etc. That that I need for printing out my hello world. That's actually automatically included when I build my Rust application. If I want to, I could get rid of it. So if I came back into my Rust code for a second, if I added another attribute, which is hash no std. So if I then get rid of that println macro, do that let's save there, for example. So now if I come back to my Rust compiler and then I run that, I'm going to get a different error here. And you can see there it's coming back with panic handler function required but not found. And you're getting this thing about personality. And underneath the hood, all that panicking functionality, in the same way with the println as a macro, you've got the same thing occurring with panicking. So when all of that is macros there, it's part of standard lib. So if I take standard lib away, then it's going to start giving me issues with the panic. Now, if I want to, I can get rid of that. What I could do is actually just implement a panic handler, which is going to allow me to, so I just pull from the core functionality. I've not got my standard lib, and then I just implement a little panic handler that will just do a little bit of a loop there. So if I do that, and then I run this again, I'm still going to get an error because it's requiring this language item required but not found personality. Now, that's pretty easy to fix because all I'm going to do is add a -c panic equals abort. And then when we do that, my compiling is now going to work. So if I were to then run my linker again, and I were to run my hello, you can see it's terminating, but now I've not included standard lib. So coming back to the point, if I come back to my hello.c that we included there, all of that is to say that underneath the hood, in C, I have to do this include standard io.h. But actually in a Rust program, that's all taken care of underneath. Now, it's a little bit of a pain to get rid of standard IO, the standard lib, but it's taken care of by Rust underneath. So this is why, if you think about it, I get this really sweet function, which is my fn main, and println hello world there. So unlike C, where I have to explicitly include my standard io.h, which has got the macros for printf in this case, I don't need to do that with Rust. It's all taken underneath the hood, right? The standard lib stuff is all part of that. It's a bit of a pain to remove it, but it's taken care of. Now, the second thing that you want to see here is you've got to return a value. So you see the main function that I've got, I need to return something. Whereas in Rust, if we come back to here for a second, you see I don't need to return anything. That's taken care of underneath the hood. But what I could do, if I come back to my C code for a second, technically what I could do is I could run this code and get the same result. Let's come back into my C code for a second. Let's clear this. So if I do a clang minus C hello.c, so that's my C file, and I do a -o, and I want to do hello.o, then what that's going to do is create an object file. And that's exactly, if we come back to the Rust code, exactly what we did with the Rust compiler. It produced a hello.o. And actually underneath the hood, there's a Clang compiler, etc., to produce that sort of object file, as you've seen earlier. And then what I can do here is if I take that sort of same linking command that I've got here, let's just take that, and then we paste it into here. I mean, I'm going to get an error because I don't have an underscore start, but if I get rid of this and then I go back to an underscore main, I'm linked again. And now I've got my executable and I can run .hello, and you can see it says the hello world. So, you know, the linker that I'm using and Rust is using underneath the hood is the same as what you're using for C. So Rust is doing a lot of cool stuff for us underneath the hood. So let's kind of come back to my Rust code in a second. But as I said, I mean, the last thing I want to do is underneath the hood there, you've got that. It's probably one of the key things. Remember, you know, termination, and we're going to go into this in a second. Termination is actually an underneath system call here. So in C language, what's actually happening is when I do that return 0 on my main function, all of that's kind of pushing back the way, and then I'm making a call to a syscall to terminate. That's actually what's actually happened underneath the hood in this case. So if you think about it, that's being taken care of in my Rust code as well. So if I come back to my main.rs, where it's just a void, I'm not really dealing with this. Now, what I could do is do a std process exit here. So let's do that. If I did that, then that would do the exit. But of course, I've just got rid of my std there. So I couldn't do that. I mean, I could get rid of this and then I could run a different exit code. So I could put exit 101 or something like that. We could come back to our code, do a Rust compile. Let's get rid of the panic abort for a second. We could do a Rust compile, and then I could do my link. And then I could do my hello, and then it would return me a different return code. But of course, if I try and put my no std in there, I'm going to get an error on the compile because I've literally just told it to use std and then it's not available. Okay, so there we have it. We're fully on our way to understanding how Hello World works in a Rust program. We so far understand how the build and linking process works within Rust. We understand that the standard lib is actually included and we don't need to do any sort of imports, unlike C. We understand that every program must have a global entry function, and by default, Rust is using main, but of course with a little bit of messing around we can change that. So we're going to shift gear now, and in the next video what I'm going to do is we're going to show you how to actually build the Hello World without using the println macro. So we'll go into the detail of the macro, and then we'll actually build our own version in inline assembly. Anyway, I hope you've enjoyed the video, and I'll catch you on the next one.